Hi all, welcome to part 2 video lecture on sequential circuits. So in part 1 what we seen is fundamentally what is a sequential circuit. We try to understand the concept with the help of some fundamental examples, so particularly that counter circuit, right? Hope it is clear to you. So what was the conclusion in the last part? It was like a sequential circuit is something, basically it is a combination circuit, okay? So you can see some combination circuit. One second. Some combinational circuit with the input, the present input and some output. So this is fundamentally a combination circuit. Now this output itself, if you are storing into something called a memory element, so we can save it inside a memory element, and from there you are taking the output, see, and you are feeding it back to the circuit as an input. Okay, so typically the whole thing is what we call as a sequential circuit. So fundamentally sequential circuit is inside sequential circuit, you can see combination circuit only, but combination circuit with the feedback paths, like that I can say, or combination circuit with a memory element is what we can call as a sequential circuit. Yeah, circuit. Now the question is, so how to do this saving part, right? So the memory element is actually saving the information, and from there you should be able to retain it, right? And later on you should take it to get the current output. So the in any given sequential circuit, the output, so the output depends on the input, the present input, as well as the previous output that is given in the form of a feedback circuit. So from the memory element you are taking it, right? Now, so how to save information? That is my question. How to save information? So basically, information is in the form of zeros and ones, right? So save something means you have to save this binary. So if you are capable of saving a single bit, so the question is, can I save one bit of information, right? So can I save one bit of information using some circuit? We will see how to save a single bit. So if you can do this, yes, then you can save any number of bits, right? Then suppose say to save this particular information, some random information I am taking, this particular one bit of information is saved by device D. Some device I implemented, and using this particular device D, I am able to save a single bit. Now to save an information, say here you can see 5 bits are there. What you have to do? You connect the same device, right, 5 times. Same device you are taking 5 times, and now each device is capable of storing 1 bit, right? So this can save this, or it can remember this one, and this one can remember this 0, this one can remember 1, this one can remember 1, this one can remember 0, so that the whole information is being remembered by the circuit. So this is a fundamental idea how to save the information. It's not only saving, actually retaining. After some time you should be able to get the information back. You should retain it. Simply, whenever I'm telling you something, you can keep that in your memory, right? So I'm giving you a lot of information, right? So are you able to save it in your mind? Oh yes. But the main question is, are you able to retain it at some later point? Maybe I am asking the same question, something like what is a sequential circuit? I explained in part 1 of the video, right? And now also I am explaining. And after 1 week I am asking you, what is sequential circuit? Are you able to retain that information I given you, or you in your university exam, are you able to retrieve from your memory? So to retrieve something from the memory, you should be able to retain it in the memory, right? So that is the challenge. So simply keeping something somewhere, it's okay, but at some later point am I able to take it back? So that is a question. Can I retain it for some longer time, right? So that is a crucial question. So can I save is the first question. Now the second question is, can I retain? Now the question of retaining matters, right? So retaining some information is actually what matters. So let's see a very fundamental circuit that can save one bit of information simply. So I can call it as a very fundamental memory element, right? And see, it's made up of only two NOT gates, right? Two NOT gates are being used. So what I done is like the two NOT gates I connected like that. This is the first NOT gate, the NOT gate 1, and here I have the second NOT gate, right? Now what will happen is you fed some information into the circuit. So right now we are not worrying about how to fed the information. Say assume that I fed the information 1 is fed into the circuit somehow. So this x is a variable, it can be 1 or 0. So at some way I inserted this 1 into the circuit. So right now you don't have to worry about how this 1 is trapped inside the circuit. That you don't have to worry, that we will see. So as of now, this NOT gate is a unary gate, right? So unary operation. So it will have a single input and a single output, and the output is nothing but the negation of the input, right? So 1, the output will be its complement 0, and similarly for 0 the output will be something like a 1, and now this 1 is coming back, right? So this is a feedback circuit. So what you can see from here, I am taking something here, right? So this is the kind of feedback we want, right? So some kind of feedbacking is there, and so that this 1 is coming here, again I am negating it, I am getting 0, again 1, right? Like that I am getting. So if I am taking this as my output, so I am just taking it outside the circuit. So this is the circuit I am having with me, and I am not worrying about what happened inside the circuit. What I know is this circuit, whenever I am taking output from the circuit, I am always getting a 1. How I am getting this 1? Because some way I fed this 1 inside the circuit, and right now we don't know because there is no user input facility. From the circuit you can only take the output. So if you want to input, there should be some other way. There is no user input facility for the time being. So simply I connected two NOT gate and I got this 1, and you can see that this 1 is indefinitely stored in the circuit, right? Unless you fed some other information into the circuit. So if you are feeding 1, that will be retained in the circuit indefinitely. Same way you can feed 0 also. So here this is how you fed that 1 into the circuit, and if you are taking this output like this, you will get 1 always. The circuit will stay in this state indefinitely. So what kind of state? Retaining one state. Similarly, if I fed 0 instead, this 0 will be complemented like 1, and again this 1 will be complemented like 0. So if I am taking the output like this, that is my choice. I can take output from any point. So here I am taking from here, so that I will always get the output 0. So some kind of saving and retaining is happening. So whenever I am taking the output, that 0 I saved, that is the assumption right now, I am able to get that 0 as the output. Now how I saved the 0 is the next thing, because if you want to save something, there should be some user input facility by which the user should be able to save some information. Here the saving part is not happening, but only retaining part is happening. Once something is saved, that will be retained. So this circuit is capable of doing that. Now the question is, can I modify this circuit? So this is the current scenario. So this one I can use, because if I am taking the output like this, I can use it as a way of storing 1, because I will always get this 1. Okay, and here this work like something that store a 0. So whenever you take output from the circuit, you will get a 0 all the time. So it is storing 0, this one is storing 1, and you can take it also. But how that storing is done, so that is missing here, right? So the circuit can be in two possible states. Either the circuit can store a 1, so that is one state, and another state is it can store a 0. Okay. Yeah, now the question is whether the circuit is storing 1 bit or 2 bits. So that is my next question. So what I am trying to say is, fundamentally this is a circuit I shown you, like there is one NOT gate, there is one more NOT gate, like that, right? And from here you are taking the output. So this kind of a circuit is what I am having. Now if I am feeding some 1 here, I will get 0 here and this one. So the circuit is always giving me 0 from here. Now the question is, can I take, so from here I am taking the output. Now I am taking the output from here also. So there are two ways for me to take the output. From here also I am taking the output. Okay. Now what will happen, from here you are getting, see, let me draw differently. Yeah, so I am taking output from here as well as I am taking output from here. So here also I am taking the output. Yeah, okay. And you can see that if you take the output from here, you will always get the 0. Here I am getting 1. So is this circuit capable of storing 2 bits? So somebody might be having this confusion in your mind, storing 2 bits. Okay. So what you are thinking, like here, see, it's looking like it's storing 2 bits, right? Like I'm getting 1 always from here. Here I'm getting 0 always from here. So it can store both 0 and 1. Right, if you want something different also. But actually, you know, this is wrong. Your judgment is wrong. The answer is no. Why it is so? Because the reason is, the explanation is like this. Storing 2 bits means what? 2 bits means you should be able to store any combination of, then only I can say like that, right? Combination of 2 bits. So you know, 2 bits, in how many ways it can appear? It can be of 0 0, it can be 0 1, it can be 1 0 or 1 1. So we don't know. So I am saying that I purchased this circuit, and the one who solved this circuit to me is arguing like the circuit is capable of storing 2 bits. Is his argument correct? That is my question. So my requirement will be, at any time I want to store 2 bits, means I should be able to store 0 0 0 1 1 0 or 1 1, right? So it can be anything. So if I am saying something like this in a general way, it should be capable of doing all those things. But you know, here it is capable of doing this one only, right? And if you want, you can modify in such a way that instead of 1, some way you are able to feed the input also, so that we will see how to give user input to the circuit. In that case, it can store the 0, it will come like 1 here, it will come like 0 here, so that from here you will take 0, from here you will get 1. So it can do this also, right? Suppose this user input is also there. Now what about this one and this one? That is my question, whether it is capable of storing 0 0 and 0 1 1. Right, the answer is definitely no, because I made the circuit in that way, because 2 NAND gates is what I am using, so it's not capable of. So you can't change the output always. So the circuit means once you are having it, output you will take from 2 points, okay, and you should be able to represent all the 4 combinations, and then only you can say that the circuit is capable of storing 2 bits. But here it is not capable of storing 2 bits. It can store only 2 combinations. That is not enough, right? But you know, it can store single bit for sure, because if you want to store 1, you use a circuit like this. Somehow you fed that 1, you will get this 1 always. Here it achieves the storing of 0, but it never achieves storing 2 bits. Okay, so that is the conclusion. The circuit can store only 1 bit of information, and basically we need this one only, 1 bit of information. At any time I want to store 1 or 0, and accordingly, you know, if I want to store n bits, that many circuit I can make use of, right? Like n circuits I want like this, that's all. Okay, so that is a general thing. Always we will try to store 1 bit only, because for storing 2 bits and all, circuit becomes complex actually. So here itself, this is not capable of storing 2 bits. That understanding is what is needed. Now see, what I am doing is, the main problem with the circuit is, so it's not storing 2 bits, that is fine, but the problem here is, the main problem here is, no facility for user input. Okay, the circuit, there is no way for us to feed the user input. So can I modify the circuit in such a way that it can take the input from the user also? So that is the question. So what you can do is, you try to replace this NOT gate with a NAND gate. And do you know how to implement a NOT gate with a NAND gate? When we discussed that universal gates, NAND gate as a universal gate, I explained you how to represent this negation using NAND. So simply this one, I hope most of you remember this. If you are not able to remember, we will see. So the first NOT gate I replaced with the NAND gate, and you know NAND gate is of two, will take two inputs, right? The same thing, there is no change for the circuit. That is what I am trying to say. This is nothing but NOT gate only. This is the implementation of NOT gate using NAND, and here also this is nothing but NOT gate only. The previous implementation only, but instead of NOT gate I used what called the NAND gate. Similarly, the same thing you can implement using NOR gate also, because both NOR and NAND gate you can use like a NOT gate, and that implementation we already seen. If you are not remembering, I given this slide also. See, this is what is our requirement. Whenever I am applying something, I should get its complement, right? So I may able to do the same using a NAND gate like this. For both inputs of NAND gate, I am just applying a single input. But you can see that the NAND gate typically it's a two input circuit. Two input circuit means the possible inputs are like 0 0 0 1 1 0 and 1 1. But you can see that in this particular NAND gate, as there is a single input, right, x only I am applying. X, when I am applying this x to be 0, right, x to be 0, this is like a 0 0 combination it will take. When I am giving x to be 1, it will be taking 1 1 combination. So it is not going to take this combination or this combination, right? So that understanding is needed. Yeah, these two things are let me write it like a impossible combination. That is enough. So that is somewhat, this is hidden from it, right? So like you know this. Now it is nothing but the 0 0 corresponds to a single 0, right? You are getting its complement as the output. It is so this f is nothing but the output of this particular gate is denoted by f, right? The NAND gate. So that is nothing but x dot x the whole bar. This is NAND operation, right? Yeah, here I am getting 0. So this is exactly this one, right? There is no change. The only thing is two input digital gate I am using, but I am giving a single input to both the inputs of the gate, right? So that these two combinations are like these things are hidden. These things are impossible. That is the correct term. The same way you can visualize a NOR gate implementing a NOT gate like this, right? Okay, so hope it is clear. We already seen, or simply this NOT gate is nothing but this kind of an implementation of NOR, right? So that is what we done. For both the NOT gates you can either replace with the NAND or you can replace with the NOT. The same functionality will be achieved. I mean you can store that, you can retain that 0 as well as 1. Now what about the storing part? Now what we are going to do next is, see, this is what we are having, right? Something like both inputs I am applying like common. Now what I will do is, the first input I will give like this, right? Now the second input here, this part I am removing, this I will take from the user, something like this. Similarly here also this second input I will take from the user, say B, and this I will give as it is, right? Hope it is clear. So this kind of a modification I am doing, right? So this NAND or NOR gate both are capable of accepting two inputs. For the time being, to get the feel of that NOT gate, I merged both of them, and I am telling you like there is no change for the value. Now I am just doing a minute modification. First input I am taking from the user, and the second input I am giving as before. Here also first input I am taking from the user, say A and B, and second input, okay. So that is what is shown here. Here the first input we are calling as set. You don't worry about this terminology right now, because why it is set, why it is reset, we will see later. So as of now, this is something, say an input A taken from the user, and this is another input B taken from the user, and we will see how it is working. Later on we will see why this A is called as set input and B is called as a reset input. We will see this later. So hope the circuit is clear. The same NOT gate only that I replaced with a NOR gate, or I can do the same with a NAND gate. So whatever thing you want you can use. Fine. Now instead of applying both inputs as common, one input I separated, and that I am taking from the user for both the gates, and the other one I am giving just like before. And now let's see whether it is capable of doing that storing part and retaining part like what we seen already. Okay, so that we will see in the next video. Hope it is clear. Thanks for watching. Yeah, if you have any doubt, it will be cleared in the next part. Okay, so please be patient and watch 2-3 videos along with that, and together if you have any doubt you can ask me during our discussion class. Fine.